this evening, I'm going to go over my thoughts on threat modeling. And I'll go ahead and preface all of this with a few things about where these thoughts are coming from. I started out as a developer, and I am of the mindset, and I come to this with a focus on having developers think about threats and use them to understand and really own functional security requirements. So it's one of the perspectives you can have on threat modeling. Coming from that perspective has driven me to follow a particular methodology and like a particular threat identification process and to like a couple of particular modeling tools because they're well suited to that perspective. This is not the one true way of threat modeling. It just happens to be one that I think works very well if you're attacking threat modeling from that perspective and for that purpose. So I think I've put enough weasel words in front of this. I can go ahead and start talking about it. Well, who am I? Well, I'm John DiLeo. Yes, I do hold a doctorate, so I get to make you call me doctor, but that's about all my student loans got me. It's actually in applied mathematics, and now I'm doing software security. Obviously, since I have a doctorate, I was a student for a really long time, much longer than I ever should have been. I started out doing simulation development straight out of university, did a lot of analytical work for a couple of government agencies in the US. I spent some time on and off as a university lecturer in maths and computer science. I switched over to web development because it paid well. And then in 2014, I jumped lanes into doing web application security. Moved to Auckland at the end of 2017. I've worked for a couple of companies in Auckland, and now I'm at Datacom. And in OWASP, I first got involved when I was in the US. Came over here, volunteered, became one of the leaders for the New Zealand chapter. I got involved in the SAM project, and now I'm a co-author for the current version of the model. I'm on the OWASP's Global Curriculum and Training Committee. I participate with the chapters committee and a few other things in my spare time. Time zones mean most of these things are happening at 2 a.m., 5 a.m., so they don't really interfere with work hours. Right? Well, what do I do for my day job? I'm on the application security services team at Datacom, and I lead up our efforts on assisting with software assurance. So we are consultants. So from an external perspective, if you'd like to pay us money, we'll help you and provide advice and consulting-led services in software assurance. Obviously, we do SAM-based maturity assessments, and then we help with laying out roadmaps and giving guidance on improvement, help people set up threat modeling practices. I present AppSec training, and then we help out in the whole governance, risk, and compliance arena, testing, tooling, risk management tooling, DevSecOps advisory, all of that fun stuff. So we do that both for external customers as well as internally, helping Datacom basically to eat our own dog food and have that same level of maturity and robustness in our internal practices. So we're doing it for both internal and external customers. So that's my day job, which does mean I do spend a bunch of time thinking about software assurance and threat modeling. And when I say software assurance, well, what do I mean? The purpose is taken almost directly from the Information Systems Dictionary in the US that says software assurance is that level of confidence that stakeholders have that what you're delivering is free from vulnerabilities and functions as intended, ... and does not function in any ways that are not intended. So you have a specification for what the software should do, and your software assurance is a mechanism to give that confidence to everyone involved that it does everything it should, as it should, and it doesn't do things it shouldn't. The goals of a software assurance program are to get that secure by design culture in place, to improve code level security of all the software you deliver, that you focus on threats and you make risk-based decisions about what requirements you should have in place. The argument around increasing development efficiency is think about it up front, build security in from the beginning so that your application is secure by design. You don't find yourself bolting things on in the last minute and having them not work. You don't have rework. You don't have those 11th hour struggles to deal with a pen test finding because nobody thought about that aspect of security. A goal of the program is to make sure that everyone involved understands what they should be doing, and more importantly, why it's important. And then, of course, we want to be able to look at, well, how mature is our program? How could we make it better? So having a SAM-based self-assessment as part of that is something that I also encourage. Where does all of this fit into where does threat modeling fit into all of this? Well, in the OWASP SAM model, under the threat assessment practice, so one of the 15 practices is threat assessment. One of the 2 streams in that practice is specifically threat modeling. And the different levels of maturity are basically how good has your organization gotten at doing it. So at level 1, you're just doing modeling kind of ad hoc. You're putting out your best efforts. Some teams are doing it, some aren't. At level 2, you've developed some standards. You've adopted a process. You've adopted specific standard tools, and all teams are expected to be doing it. At level 3, you're learning from everyone's experiences, improving and optimizing your processes, improving tools, building up templates, building pre-built libraries of partial models in order to make the process more efficient and have more consistent modeling across the entire organization. And where possible, and assuming the budget's there, you could even introduce some automation. There are some commercial threat modeling tools that can provide some level of automation in developing models. In the Microsoft SDL, it shows up as a practice, both in the earlier simplified SDL and the current one. Perform threat modeling is one of the core practices. In the BSIM, threat models appear in 2 different places, in the attack models practice and in the architecture analysis practice. So the whole point of this is whatever software assurance or secure development program you're looking at, you're going to find threat modeling mentioned. It's part of what we should be doing. Well, the key thing about this is we're trying to answer a question: how can we go about finding security issues in our systems? And what we really want to do is find those security issues before someone else does, whether it's one of our users in production or it's a state-sponsored threat actor coming at us from one of those countries in Asia. Then we want to find those issues before they do, address them before they can be exploited against us, so that we can keep our users' data safe. So some ways that we could do it: well, we can do static analysis and go, oh yeah, that looks like some pinky code, we should fix that. We can use dynamic testing like ZAP to try and identify issues. We can bring in third-party penetration testers and have them tell us all the horrible things about our applications that we kind of knew, but we're hoping nobody would notice. We could just rely on users reporting problems. Or maybe we could wait until there's an incident, and as part of the incident response say, oh, maybe we should fix those things. But as Adam Shostak says, wouldn't it be better if you found those issues before they ever appeared in code? And that leads us to thinking about threats ahead of construction. Now, the first thing I like to talk about, I call it the 5 W's of threat modeling: who, what, when, where, why, and how. So first, why do we do it? As I mentioned before, we want to improve efficiency. We want to think about security issues early on. We want to invest our development effort more wisely. So, and it would help if I had that displaying on the screen while I talk about it. And then invest effort more wisely is if we've thought about the threats, that when we say we want to implement a feature, and right at that point, we have the conversation that leads to, yes, and in order to make that feature secure, we're going to do this and this and this. So that from the very beginning, we've thought about as soon as that feature is exposed, it's going to have these security controls implemented in order to make sure that it's presented in a way that is safe for our users to use it and provide their data through it. And because we've thought all of that through from the beginning, if we discover a real showstopper threat, something that we cannot adequately mitigate, then that can lead to the conversation about, do we really need this feature before any time is invested in building it? It's really sad if your developers invest, say, 6 developer weeks in producing a really sexy, very cool UI feature, only to discover that it's so inherently insecure that you just cannot turn it on. It would be much better to have that conversation beforehand and say, there's no way we can make this safe. Let's try something different. It allows you to understand requirements better. By having this conversation happen up front, it allows development teams to understand the security concerns. It allows the security analysts to understand what the development team is trying to accomplish. And it gets everybody this shared understanding of the risks. And then, of course, we want to avoid rework because it's expensive. Going back to that software assurance definition, we want to improve stakeholder confidence. One of the nice things about having a robust threat modeling program and a nice catalog of maintained threat models is that independent assessors really like that. When you are being assessed against any of the many certifications, 27K or high trust in the US, and you say, oh, well, here's our threat model catalog, and here's what we came out of the threat model, the threat modeling on the application that's being certified. Here's what we came out with for our findings. Here's what we decided to do for mitigations. Here are the past tests. And they go, oh, yes, you understand this. And it improves their confidence. The third-party assessor has this improved confidence that you guys know what you're doing. And it can often shift the tone of the conversation with the assessor. Very quickly, some terms of reference, simply so that you know how I'm using the terms when we talk about them later. An asset, whatever it is that we want to protect. A threat, it's anything that could let someone or something obtain, damage, or destroy an asset if we fail to protect against it. Now, in threat modeling, we add that last part because we want to go into the conversation about the threat model, recognizing that let's just assume we didn't protect against anything. What could happen? And then we can start giving ourselves credit for the protections that we know we're going to build in. But we should not frame the conversation in the way of saying, oh, well, that's not a threat because we've protected against it. No, it's a threat that you've protected against. So you want to change that mindset and say, all right, well, at first, well, we're just trying to identify what could go wrong. Let's forget we've protected against anything. Then as we start to talk about what protective mechanisms we have in place, we're getting to the point of trying to understand, well, what are the remaining vulnerabilities, the gaps in our protections? Because vulnerabilities can give rise to risks. And what we're really trying to do is minimize risk. So risk is the potential for loss, damage, or destruction of an asset because a threat was able to successfully exploit a vulnerability. So what's a threat model? Well, it's a conceptual representation of a system and the threats that have been identified. And what's a model? Well, it's an abstraction. And it's an abstraction that's built for a particular purpose. So one of the things about this is very often when you get into threat modeling and you say, oh, we need a data flow diagram, the very next thing the architects are going to say was, well, can't we just use the environment diagram? And the answer is no, not really. The environment diagram or the interaction diagrams that they have were built for a different purpose. And they're perfectly adequate models for the purpose they were built for. They could be a great starting point to get you a good DFD to do threat modeling, but they're almost never usable as is. Some key considerations about a threat model. To be useful to more than one person, it has to be captured in a persistent shareable form. I bring this up especially in a room full of developers to say, you're doing threat modeling all the time. We know you are. You're thinking about threats. You're deciding to use a particular security function to set up your access controls and so on, because you're thinking about these things. But who else knows? So it's at that point where you say, we want to capture this. We want it to be a shared artifact that everyone can look at and understand, so that you're not the only person who understands what was considered in deciding how to implement a particular security feature. And then the model, in order to remain useful, it has to be kept up to date. Threat modeling is never a one and done activity. You have to keep up with changes to the system as new features are added, as the application is replatformed. Each time those changes are made, you need to review the model and update it to keep it in sync. What should be in a model? Well, describe the system, list any assumptions that you're making, list the threats that have been identified as you've gone through your modeling exercises, capture the decisions that were made on how you're going to address each threat, whether that is we implemented a particular set of controls or we've decided to accept the risk and we've got this signed risk acceptance memo. Get all of that captured. The verification approach. How are we going to make sure that everything we're putting in place actually works? It's surprising how often that gets overlooked. A decision is made, oh, we're going to turn on this control. Okay. Is it turned on in production? Did anyone check? And one of the first times I asked that, working with a group here in New Zealand, and there were just a couple of face palms in the room, like, really? We're supposed to check that? Yes. And then the validation approach. How are you going to go about validating the model? When have you validated it? On what dates did you recheck assumptions? What input did you get? Just keep track of that. So really, the model is a bunch of information. And as we get to some of my thoughts on what it should look like, the answer is whatever works for you, as long as you're capturing all that information. Now, who should be doing this? A key thing is a threat model is not something that some security expert should come in and build for you. It is really, it's a shared understanding document that needs to be built by the stakeholders. A security expert like me or Nigel and his team, where they've been doing a lot of threat modeling already, they should come in and help make sure that you're asking the right questions and that you're capturing the answers in a usable form. Help keep the conversation steered in the right direction, pull people out of rabbit holes. But they should not be telling the development team, here's what your model needs to be. That it's not helping. Now, remember that my caveat before I started, this is from the perspective of trying to use threat modeling as a source of meaningful software requirements. You want the development stakeholders to be there in the room and to own these conversations. So the business owner should be represented, the testing team should be represented, your lead architect, your core developers, your UI, UX designers should have a stake in this in order to take part in these conversations and understand why particular constraints are placed on the app, or we've added in the extra 2 weeks of development to implement some features because it came out of this exercise they were part of. Now, the model needs an owner. There needs to be someone who's accountable for making sure the modeling is getting done. And then there needs to be at least one designated maintainer who's responsible for doing updates. Now, in many cases, the owner might be the product owner, because it's a business function to be accountable for it and to make sure that the time is budgeted to get it done, while the maintainers might be a couple of your developers who are actually going in and updating your model files. When should you create the model? Absolutely. It's like, the right time to plant a tree was 20 years ago. The right time to build a threat model was when the project started. The second best time is now. If you've got an existing system and you don't have a model, or you let the model get out of date, well, then you can use an incremental approach to get the model caught up, but start now. When should you update it? Well, I have some recommendations around this, and this is what we're currently using with some teams. You review the threat model every update cycle. And on one team that I work directly with, that's every sprint. We asked the question, we brought some backlog items into the sprint. We're going to be working these. Do any of these affect the threat model? If the answer is yes, then the model gets updated during that update cycle. You commit some story points to doing the updates. So to answer that question, what's an update cycle in an agile process? It could be once per release, could be once per sprint. You could be doing this on a story by story basis, as Izar Tarandoc recommends. I'm not personally in favor of that. I think looking at it for the entire body of work in a sprint is a good level. If you happen to be in a waterfall or a contract-based development environment, well, every time a new change order comes in, that's a new set of requirements. As we start planning out the features, let's update the threat model. Where should this thing live? I'm stating a few obvious things. It should be in a well-known location. You want reliable backups. Source code repository comes to mind immediately. Version control is great. Having model version names aligned with product version names is a really great way to keep track of them. Where it should not live is on the senior architect's laptop with no backups. That's really the key thing, is it needs to be shared. Everyone needs to know where it is. It needs to be under version control and protected from loss so that everyone on the team can access it. Updates can be made as they're needed, and you always know where to find the latest version. So how? Given the fact that my goal is to enable development teams to do this as part of their routine practices, we're looking at a software engineering compatible approach. We want something that's repeatable. It needs to be decomposable so that you can look at pieces of the problem at a time. It needs to be scalable so that lots of teams can be doing it all at once. Clearly, it can't rely on just one or two core resources doing it all for everybody. And that leads us to what Adam Shostak puts forward as the focus on what's being built, the what are we building question. Because ideally, the development team knows what they're building. They understand that. They have a context around it. They know what it's supposed to look like. They know what the pieces are. And it's something you can test. So that by focusing on what's being built, we're able to bring it into the working context of the development team. It's not some abstract thing that they have to try and shift their thinking to. Which leads us to a threat modeling approach, which I humbly call DiLeo 7 questions. Now, it is an expansion on Showstack's 4 questions, so this is not totally original. The first question is, well, what are we building? And to answer the question, my recommended approach is you create a data flow diagram. What can go wrong? You want to identify the threats. And my preferred approach is to use the stride mnemonic for that. What might we do about it? I'm missing some words there. So identifying the possible mitigations that we could do. And then narrow that down to what we will do about it. So actually select those mitigations. And then a key question, which this is where I add in, I say, now you've considered all the things you might do, and some of them seem to be really hard, really expensive. So we're only going to do these few things. That's great. Now, look at the residual risk that you're leaving on the table because you've chosen to do only certain mitigations. Does the business owner accept that risk? If no, go back to 4, choose something else. So you keep doing that until the core stakeholders, the business owners, the people who own the risk are happy with the level of risk that remains, and then you move forward. And then we ask the question, how do we know the mitigations work? What is our testing approach? What are we going to do to verify things in production? And the last one is, did we end up with a correct model? You know, as threat modeling is going on and building is going on, are they diverging? And if they are diverging, then we need to get the model adjusted so that it realigns. I should have mentioned this before. What I've done is I've taken an 8-hour training class that I present. I've presented a few times at OWASP events. I happen to offer it as a service through my day job that we can present this training. And it's, 7 hours of material. I'm trying to crunch it down into 35, 40 minutes. So I know I'm just hitting the wave tops here. So in creating the model, answering that question, what are we building? What we're trying to capture is, well, what are we using to build it? So is this a series of Java servlets? Is it a bunch of Lambda functions implementing APIs? What do we have that we're building? And then the key thing is, what are the data? Where are they being stored? Who's processing them? Where are they coming from? Where do they end up resting? And then what are the pieces of software being created? So this is where you have your list of, well, what are the APIs we're going to create? Are we going to do this as a bunch of Azure function apps? So we'll have 30 or 40 of them. Is it one big Spring Web MVC app that has all of the endpoints defined in one dispatcher? What have you decided to build? How is that going to function? But then we're not going to go down and emulate the code. So we're going to build a model that abstracts away a lot of the details, because what we really want to know is where do the data go? How do they get acted on? Where can they be modified? And then we can ask the question of, well, how could they be modified incorrectly? And so on. And picture's worth 1,000 words. So diagrams are really great here. Whiteboard diagrams are a great way to start. You get the development team in a room with a big whiteboard and start handing out markers and say, all right, let's draw this. How does it work? For threat modeling, we tend to focus on data flows and boundaries. Data flow diagrams are great. In a few limited cases, swim lane diagrams and state machines can come into play. I'm not going to talk about those tonight. For the most part, we're looking at DFDs. So we want to model the processes, the data flows, the data stores, where are our boundaries, and understand who's interacting with the system and where things end up. Trust boundaries in development, we often don't think about them, but we want to make sure that they're explicit in our threat models. And it's really anywhere different principles interact. Any place that you need to authenticate yourself to another process, you're crossing a trust boundary. You were not automatically trusted. You had to present your credentials. So connections between a web application server and a database server will cross a trust boundary, and so on. The point is, if there's a boundary, there needs to be enforcement, and that's where you're going to look at your enforcement mechanisms in particular. One of the things that I guess I was even a little surprised when it was brought up to me before I moved into security, as you start building client-side applications, a lot of times this is a little hard for developers to latch on to. When you deliver software to someone else's device, even though it's your software, it's now on the other side of a trust boundary. Because once it leaves your control, you can no longer treat it as trusted. It's an interesting challenge for developers often, because they're like, but we tested the code. We ran security checks on it, and it's signed, and we've minified it, and we've got it all bundled up. Of course we can trust it. No. You've allowed somebody who has complete control of the device it's running on access to it. So you have to treat it as an untrusted data source and assume it's always crossing the boundary. This is one, it can be a challenge, but once the mindset shift happens, then you can do that. Really quickly, a data flow diagram, 5 key elements: processes, data stores, data flows, external entities, in the UML world, actors, and now trust boundaries. A classic data flow diagram straight out of Adam Shostak's book, just to show how the elements interact. I'm not even really going to talk about this diagram, but you can see that we've represented a few processes, a couple of external actors, and 3 different data stores for the purpose of thinking about threats to this database account. This was the level of modeling that was selected. You can see that the data flow arrows can be single or double-ended depending on whether the data flows in one direction or not. One of the things about this is, if you think about the fact a lot of this is being done through web transactions, so there's going to be a request and a reply. Well, if we're really only concerned with the data, we don't necessarily have to represent the request if only the reply contains information. Shifting to the second question, what can go wrong? I've settled on recommending the Stride mnemonic. There are others. Linden is also fairly popular. Looking at things through threat libraries, threat trees, a number of different sources are also valid. I just recommend this one. Again, it's a good way of getting developers to think about things. So how could somebody spoof an identity? How could they go about impersonating an authorized user? And once they successfully do that, what can they do to us? What would happen if data were tampered with? What are some scenarios that could happen where, for repudiation, somebody could perform an action and then try to get out of responsibility for it? So understanding the places where we need to be able to have total accountability for user actions lead us to understand what our logging requirements are. Information disclosure. What could happen? What information do we have that somebody would want to get out of our system? And what would happen if they could? So asking these questions, and notice at this point, as we're doing this, it's absent any protections. If somebody could just come in here and take this information, what would happen? What would be the impact of that? How could they exploit it against us? So the obvious stuff of, well, if they're able to get our transactional data from our customers, then a competitor might buy that from them. So there's a financial incentive to get it. Okay. then what do we need to do to protect? And that gets us to the next question. An approach after developing our data flow diagram, and we have all those elements in it, is then we can apply stride per element by going for each element, ask what threats are there of each type. And again, now this is Adam's recommendation straight out of his book. If you're talking about external entities, then the question you're asking is, what are the spoofing and repudiation threats? If somebody can impersonate an external entity, what could go wrong? If someone could perform an action through an external interface and then deny doing it, how would that impact us? For data flows, it's about tampering, information disclosure, and denial of service. Likewise with data stores, the question mark in repudiation is, well, if the data store also contains logs, like a database management system would, well, what if they could tamper with the log data? Now they can achieve repudiation. And then you notice for processes, we need to ask across all of the activities, all of the categories. So we create this model of what we're building or what we're changing if we're doing an incremental approach. And we do that first pass for threats. We use our stride per element table to ask the question across the categories. And Adam recommends in his book, a good stopping rule for a first pass is if you've identified one or two threats in each of these categories in the row for each element. And then you can take further passes later. As you work in more detail on a feature, you can dig deeper around that one feature in your model. All along the way, try to make sure that the model continues to match the as-built system. And then the key thing about this is you want a living artifact. You want to have all of this captured somewhere where it can be referred to and kept up to date. There are lots of different ways you might do this. And here are some options. You just do it in a document. I'm not saying it's a great idea, but it's possible. You can use a spreadsheet. And if you ask some business analysts, they might go for that as their first choice. I have actually done it where the threat models were in wiki pages. So we had the data flow diagram at the top of the page, and then we had a section for each element where we listed the threats. And we basically created a table in sections. So we'd have the threats and then the selected mitigations, and it would lead out to JIRA tickets for implementing the mitigation features. You could build it into a database. I've actually seen Dennis Cruz, who's active in the UK and OWASP, he and his team put together an entire JIRA schema that allowed them to represent threats and associated risks as associated JIRA tickets. It was incredibly cool. As he was describing it and he was doing a presentation about it and was all excited, I'm like, okay, but there were easier ways to do this. But it was still very cool that they had this idea and they had actually done it around focusing on data journeys for GDPR compliance. That they created tickets for assets, tickets for threats, tickets for vulnerabilities, and then they would build the whole relationship in JIRA, and then using a very cool Python script, they could then take the information from the JIRA tickets to draw their diagrams. Okay, sure. Or you could use a purpose-built threat modeling tool, which takes care of a lot of that for you. So now we've captured what could go wrong. The next step is, what can we do about it? And at this point, when I'm doing threat modeling sessions, I try to keep the thinking open. Even if you know we can't afford to do it, let's get it on the record that we've thought of, well, it's possible we could address it this way. Let's put out all of these different things we can think of. And then when we get to the next section of what will we do about it, that's where we can make those decisions and say, you know, cost benefit trade-offs, we're not going to do this, we are going to do this. During this section, really start out with brainstorming. How could we address this? Now, ultimately, what you're going to make is a risk management decision. The threat, unmitigated, has a certain inherent risk. If you choose to mitigate it, then you are going to reduce the risk and leave yourself with some residual risk. So the first thing you can do is just say, well, okay, we want to avoid the risk entirely. We want to remove that threat completely. What that usually means is we're not going to implement the feature that gave rise to the threat. One of the really common ones, two common ones that come up in conversations about applications: file upload and free-form queries. So almost every time you talk to a business owner, they're like, oh, well, we just want users to be able to upload files. Okay, for what? Because just saying we want you to support file upload is a wide open, threat-riddled requirement. What are you really trying to achieve? Likewise with reporting, where they say, well, just give us a generic reporting tool so that we can perform arbitrary queries. Really? Have you thought about what the sorts of risks that implies? So you could simply say, you know what, we're just not going to do it. We're not going to have file uploads because they're too dangerous. Okay, but if removing that causes you to fail to meet some important business requirement, well, that's not really going to play out. So in some cases, you can say, you know, we don't need that function. We can do it we can do something different that accomplishes the same objective in a safer way, so you can avoid the risk entirely. Sometimes you're able to do that. You can implement controls to mitigate the risk, and this is where we usually end up. You can do some technical things. Well, you've got access to a lot of well-known commercial and open source solutions. So if you're thinking about how am I going to implement access control? Well, you've got a number of authorization frameworks at your disposal. You can take one of those and use it. If you're trying to deal with authentication, you can subscribe to an authentication and identity provider so that you're not implementing your own password database. In some cases, there won't be a ready-made solution to solve your problem. Or in certain instances, including at companies here in New Zealand, their value proposition is that they have security and privacy controls that themselves are the industry standard. So in those cases, you're going to be rolling your own security. You're going to be implementing, say, a privacy management function or an access control function that is very specific to your business domain, and it's very tightly coupled with your domain model. Going back to talking about access control in the first presentation. And you're going to be implementing that and investing developer effort, investing QA time and validation and verification really extensively to implement this custom security feature, because that is your value added in the market. If that's the case, absolutely. Make it great. If your product is not a security product, why are you building security products? Get the ones that are well known, that are very well proven, very well tested, and use them. You might look at non-technical controls, physical protections, administrative processes, things that you can use in order to protect from the threat without having to write new code. You could choose to do nothing because you consider the level of risk acceptable. Fine, document that. You can make it somebody else's problem in limited cases by transferring the risk. In particular, if you're developing software which you're going to sell to a customer, The customer is then going to install that software and deliver it to users. Your agreement with the customer could lay out the specific things that your software does not do and that they need to implement in the enclosing environment. You've then put the risk on them by laying out that it's their responsibility to implement those controls. In those cases, that's reasonable, unless the customer says, no, you should be doing that for us, and then you can negotiate. A little bit about custom mitigations. Main thing to keep in mind about them is once you decide you're going to build your own security control, you own it forever. You have to do all of the testing. There isn't a broader community to fall back on. You're not going to have contributors from all around the world helping you find issues like you would with an open source control, because it's yours. So very often you see a situation where a team will decide to do something custom and not really think through that long-term total cost of ownership. Or maybe they did and they just decided to make that someone else's problem. So they build it, they implement the custom security feature, they put it into production, the team is disbanded, and people forget that this software security is relying on this custom feature that nobody's maintaining. There's at least one Auckland company where that's a known issue. So you've got that around custom mitigations. Basically, go there if you have to and do so with care. So selecting your mitigations. I recommend a two-stage process. For any mitigations that are easy, mandatory, or are standards, just do them. And mark all the relevant threats as mitigated. So this is where we get into situations like, oh, well, we could encrypt the database. Okay, do that. We can make sure we're using TLS 1.2 everywhere. Yeah, do that. And then you just mark all of the threats where that is a full mitigation, just mark those as mitigated. For the remaining threats, then we can start talking about risks. What's the risk if we don't? Is that an acceptable level? No. Okay. Now let's look at the mitigations we identified. Look at their costs, look at their benefits. For how much money or how much developer time invested will we reduce the risk by how much? Then based on that, select the mitigations to apply, or possibly say, these are all too costly. We're going to go ahead and accept the risk. And if the business owner is okay with that, document it and move on. So getting to how did we do? We want to verify the mitigations. Did we do the things right? We want to validate the model. Did we do the right things? Remember, every mitigation can be tested or at least verified. One of the things I mentioned about that is, oh, well, we're going to make sure that our web servers are only accepting very strong Cypher suites, TLS 1.2 and 1.3 only. Okay. So run the SSL lab script against it and make sure that's true. Just as part of your post-deployment checks, run the script and verify that you get an A+ rating on the website. So you can test, you can have test cases, you can apply verification scripts, perform checklists in order to make sure that these mitigations are implemented as intended. If you're living in a test-driven development environment, use it. Write test cases where you try to execute a threat. And the test fails if the threat can be successfully executed. Once all of your software controls are working correctly, your tests all pass. That's a great way to go about it if you're in that kind of an environment. Because you want to be able to do this testing frequently, automate as much as you can. If you end up with hundreds and hundreds and hundreds of manual test cases, they're not going to get run. Automate everything you can. On validation, make sure that the model reflects reality. make sure that all the selected mitigations have been implemented and verified, make sure all of your assumptions are still valid, make sure that this model is a useful model. I see that I've gotten pretty late, so the last thing I'm going to show is putting a lot of this about how the threat modeling process fits into software development. Put together this lovely little diagram a while ago. So you've got an existing system where you're not doing threat modeling now. You've got an architecture, you've got some requirements, you've got existing test cases, you got some understanding of what your environmental and regulatory constraints are. Well, I want to interpose threat modeling into that. My first step is I want to model the to-be design. I want to know what the inputs are, what the data flows are, what data I'm using, what libraries are being employed, what are my assumptions, all of that stuff about building the DFD, the what are we building question. I'm going to then identify the threats, identify my candidate mitigations, and then at this point, I bring in those constraints I know about, including financial constraints, schedule constraints, anything that's specified by a regulation of you will do things this way. And that will lead us to a set of selected mitigations. And in any place where we've decided to leave some risk on the table, we get those risk-based decision memos as part of that input. Now we take those selected mitigations and we use those to drive our consequential requirements. And this is the point from my perspective, is that we've gone through all of this in order to capture these yes and requirements. So some of them will be functional. There'll be things the software needs to do, and some will be non-functional. There'll be specifications around encryption algorithms you can use, or what ports you're allowed to have open, and things like that, which will go into your spec. But in any case, all of those things can either be tested with a live test case or verified against a checklist. So you then update your body of test cases to add those in, and that becomes your testing framework. My assertion is that as development teams get into the threat modeling mindset, you can devote a couple hours a sprint to this exercise, because they can come into the conversations with the right mindset, thinking about this. And what will come out the other side is maybe 2 or 3 new tasks that need to be performed. They might be new backlog items or just some subtasks around making sure that the threats you identified have been addressed. A live example in a threat modeling session probably about 6 weeks ago. I think it was right after we came back from the holidays. We were having a conversation about one particular feature. And as we started identifying what the threats were, one of the lead developers said, oh, yeah, we should make sure that we're turning encryption on that link, because I don't think it's on right now. Oh, okay. And he goes off and he checks and says, yep, it's not on. So then in the model, we said, okay, it's currently not encrypted. We're going to turn on encryption as our mitigation. And he created a task ticket to go and make sure the encryption was turned on in our configuration files. So that sort of thing can come out of this. And because it's being done interactively as features are being developed, you're producing releases that have new features implemented securely. And that's where I really think we want to be going with this. Now I have more slides, but I think 45 minutes is enough. So I'm going to stop there and you can open mics for questions for those of you who've been hardy and stuck it out to the end. I don't see anything coming through in the messages. Nobody's unmuting. So I am going to thank you all for your time and attention. And for those of you who are watching the recording later, thank you so much for watching, and we look forward to seeing you at a future session. Good night, everyone.
Thanks very much, John.
Thanks, John. Good night.
Awesome, John. Thank you.